Hi everyone, thank you for joining our CPD presentation this morning. It's lovely to have so many of you attending. Just to let you know a few housekeeping rules for the event. If you have any questions during the event directed to Ellen or Chris, please write them in the questions box at the bottom of your screen. We'll answer 4 or 5 at the end. You can also upvote someone else's question if it's already been asked, and just try and pop on there who the question's for as well. If we don't get around to answering everyone's questions, please get in touch so we can follow up with you. And you'll also be sent an email at the end with the contact details for both Ellen and Chris. And just hang around for the last slide as well. So that's going to have all of their contact details for you on there. Just to let you know as well, we're recording the session, so it will be available on YouTube and elsewhere for future viewing. So if you'd like to go over any of the content discussed today, look out for those videos online. A little bit about the companies. So Whitecode, as I'm sure you're aware, are a international M&E consultancy founded in 1994, encompassing all aspects of MEP design. They provide a full range of consulting services within construction, from building analysis and reporting, mechanical design services, utilities consulting, fire engineering to sustainability offerings. With a highly qualified team working across multiple sectors within the construction industry, Whitecode have the expertise and the knowledge to seamlessly provide solutions from concept through to completion. And a little bit about Cass Allen. They're an independent acoustics consultancy specialising in large-scale residential-led development. They're unique in that they provide a set of guarantees ensuring all clients are always receiving responsive, clear and pragmatic guidance and solutions. These guarantees have led to delivering well over 3,000 successful projects across many of the UK's leading developers, contractors and architects. And using that experience, they support clients in taking their projects from the early planning stage through detailed design and construction, through to testing and handover. So there's a lot there. Obviously, these are best placed people to talk about this subject. So on that note, I'm going to hand over to Ellen, who's going to continue the presentation.
Thanks very much, Rob. Hi, everyone. Thanks for joining us. Hopefully you find this useful. First of all, a little bit on the agenda and what we're expecting to hear about today. So to start with, what is overheating? We're going to talk a little bit about the policies and regulations that are already in place, what you're all here to hear about, which is part O, what it means, how you guys can comply with it. So there's 2 different methods, the simplified method and dynamic simulation modelling against TM59. Tell you all about that. Then we're going to be having a look at some options to mitigate the risk. And finally, Chris is going to finish off with some of the acoustic issues associated with overheating and these sort of challenges that these offer to the sites that we're looking at. So to start with, what is overheating? So this is a definition of overheating, and it is the phenomenon of a person experiencing excessive or prolonged high temperatures within their home, resulting from internal or external heat gains, which leads to adverse effects on their comfort, health or productivity. So we're all very well aware that the climate is getting hotter, we've got a climate emergency, global warming, our carbon emissions are increasing. So in general, everything's getting much warmer. Also, people are starting to live more in apartments with lots of glazing, and houses are much better insulated. So all these things are actually contributing to the overheating problem. These 2 graphs here are 2 scenarios. So these are Met Office predictions, and obviously we're in 2022. There's 2 scenarios here. So the first one, which is the RCP 2.6, is if we meet our target for net zero carbon in 2050, which is what we're all driving to at the moment. So if we meet that, we should be able to, and we really hope that we can keep the temperature change on the planet to less than 1.5 degrees. And that's sort of like the best case scenario we can hope for now. That's a prediction there in terms of the temperature change and how it'll affect the whole world, basically. The red graph, you can see the line is going way up really high. the temperature change in the world would, if we didn't control our carbon emissions now and really tackle this global warming issue, this would mean that the temperature change would exceed 4 degrees. And we all know that could have an absolute catastrophic effect on global environments and around the world. So we obviously hope this doesn't happen, but hopefully you can see that overheating is a problem. It's something that we need to deal with. It's something that hasn't really been regulated properly in the past. And this is what Part O is all about. So before we talk about Part O, I'm just going to have a little chat about what causes overheating. So we've got a nice little house in the middle there. Not many houses look like that nowadays, but never mind. So we've talked a little bit already about everything getting hotter from the sun. So we've got solar gains through glazing. And that's where the majority of solar gains come through, as you can imagine. But we also get solar gains through fabric. So when we're looking at fabric, if we've got things with a high thermal mass, for example, we'll find that they respond differently to heat. If you've got a lightweight construction, then that's going to heat up and cool down very quickly. You'll find a lot of solar gains are actually transmitted through the fabric as well. So that's sort of thing you have to think about when designing buildings. Obviously, we've got internal heat gain, so you've got those two people having a little dance there. We have people obviously living in these dwellings, so we take into account when looking at overheating the occupants, what they're up to in the different rooms compared to what they might be doing in the living room or what they might be doing in the kitchen. The appliances they use. Now, we have all started to use a lot more appliances. Some houses may have a couple of PlayStations, TVs everywhere. These all obviously produce heat. So this contributes to the internal heat gains. Not only have we got sun coming through the window and it's getting hotter outside, we're using more electrical items inside, which are causing internal heat gains. Alongside that as well, obviously, is building services. So that's why it's really important to make sure that building services are well insulated, because what we don't want is to provide the heating, but it all sort of escaping out the pipes and actually heating those rooms, which in places we don't want them to be. Another thing that affects overheating is how much ventilation we can get. So obviously through windows, and the ideal situation is that we have openable windows, and we're going to talk a little bit more about this later, but that obviously affects it. So the number of openable windows you have has a massive impact on how much overheating, because as you can imagine, if it gets really warm during the day and you come home from work and you're able to open your window, let that warm air out, then you can obviously reduce that overheating feeling. Also the impact of ventilation to infiltration. So that's a little bit related to how airtight your building is and whether you have mechanical ventilation. In terms of building design, linked with what I talked about earlier with thermal mass, insulation, how airtight the building is, and if you've got single aspect dwellings. So all of these things about building design, I talked earlier about the fact we're driving towards net zero. So here I am as an energy assessor saying to everyone, right, what we need to do is we need to get great insulation, reduce your air tightness, make sure you've got great window performance. And actually, that is actually contributing to the overheating problem, because the more airtight we make our buildings, the more insulation we put in, the harder it is for us to get the heat out of the building. Obviously, other implications on building design are things like having single aspect dwellings. So where you don't get that cross ventilation, particularly, you've got apartments on west or south facing orientations. It's great if you want a nice, lovely, bright light flat, but you'll probably find that you're going to have an issue with overheating. And there's other things that can affect overheating as well. And this is where Chris is going to come in a bit later to talk about specifically the noise issue. But where your site is, it's going to have an impact about how hot you're going to be feeling if you can't open windows, for example, because you're on a ground floor, because you've got security risk and you don't want to have your windows open overnight, or you're on a very noisy area, or you have air pollution problems. So as you can see, there's lots of causes of overheating, and there's lots of things that can go into it and can affect the results. In terms of policy and regulation that has been out there before we talk about Part O, those of you who do developments in London will be familiar with the London Plan. It was released in March 2021, and within that is policy SI4, which is to do with managing heat risk. And this is specifically to do with overheating. We have been working with the draft London Plan since 2018, and this is all related to the decarbonisation of the grid and the lower carbon factors we've been using. So many of you, if you've got large developments in London, will be used to completing TM59 overheating reports for London Plan compliance. This was all great. We would do a sample of the dwellings and submit it at planning stage. However, there's not really been any regulation on this. No one's actually checking Has this been done? Have you put your blinds in like you said you were? So it obviously it was a good start, but there was no regulation covering this. Part of TM59 and is following the cooling hierarchy. So what you can see on the right-hand side here is the cooling hierarchy, which is actually taken straight out of the London Plan. There's the little London Plan booklet if you wanted to look that up and read it in full. Probably not. But yeah, so the cooling hierarchy, you have to follow it. So number one being the thing that you should consider first, all the way down to number 6, which is sort of like the last option. So we've talked about it a little bit already, but the first thing you should be doing is looking at the fabric of your building, the amount of windows you have, how your building is orientated, how much shading you have, everything to do with the design. And this is a key thing in terms of overheating, that this shouldn't be thought about later on down the design once you've already sort of designed, got it through planning. This should be, you know, one of the first thoughts now when you're sat there, if you're an architect, for example, starting to draw up some designs with, you know, with your client. Overheating needs to be at the forefront of your mind, because you can really make a massive difference in terms of reducing the risk of overheating if you have good thought on orientation, shading and things like that. So that's the first thing you look at. Then we'd want to minimise the internal heat generation through efficient design. And this is really efficient service design. So again, I said it earlier, but in terms of insulating pipe work, making sure you've not got loads of heat coming off of HRUs and things that shouldn't be there. So that's really important. And then there's other ways of managing heat within the building. These haven't been used so much so far, but I think going forward, you might find that these have become quite useful tools. Things like having exposed thermal mass. So for example, ceilings which don't have plasterboard on, you know, if you leave them exposed as concrete, you can then use that thermal mass to deal with the overheating. Even perhaps doing that in corridors and things like that, or stairwells, can help increase that thermal mass of your building. So we look at all that first, and then we look at how we're going to ventilate the building. And ideally, we want to provide passive ventilation through openable windows. And that would be, you know, it's also things about how big the windows are, how much of the window opens, and I'm going to talk a little bit more about that in a minute. Once we've looked at all the options for passive ventilation, we then look at mechanical ventilation. So quite a lot of mechanical ventilation is usually required for Part F anyway. There has also been an update to Part F, in case you didn't know, so have a look at that as well. But in terms of mechanical ventilation, we're talking about things like whole house extract or mechanical ventilation with heat recovery. So whole house systems which provide continuous mechanical ventilation. They alone are not really enough to mitigate overheating risk, and we will talk about that in a minute as well. The absolute last option, the last resort, is to provide active cooling systems. So this could be full air conditioning or comfort cooling, where you literally cannot do anything else to cool those rooms off. So this, as I said earlier, is part of the London Plan. And whenever we look at a site at planning stage, we sort of review this cooling hierarchy and follow it to satisfy the London Plan and the GLA. In terms of other regulations, and I haven't put it on here, but those of you who know about SAP calculations and compliance with Part L, currently in the Part L 2013, there is a couple of tick boxes at the end of the SAP calculation, which basically says, when are the windows open? No, I think open fully all the time or open partially. You can tick that box and you can say what the air change rate is, and that's it really. That's all that has been there for regulation for overheating for many years. So, and it's quite easy to overlook that. I know in terms of compliance, there's not really been any full compliance required for overheating until now, which is Part O for overheating. So this is a brand new approved document, and it comes into force in June 2022, 15th of June actually, and it comes alongside the new Part L. And as I just said, there's actually a new Part F and S as well, which is to do with electric charging. So this is coming in, and this is a new approved document. So basically, anything that you submit for building control initial notice after June 2022. You are going to have to comply with Part O, and this is going to have to be information provided to your building control officers to tick that box to say, yes, we have looked at overheating, we have assessed the overheating, and we have managed the overheating. So For the past few years, when we're doing planning reports, we may have presented some information to our clients saying this could be an overheating risk, but it was really just a risk assessment, and there was no sort of comeback in terms of who was actually looking, regulating it, and checking that it was done. So the new Part O applies to residential dwellings, institutions, and student accommodation. So it's really important because obviously everyone lives in houses. Lots of people are living in very highly glazed apartments now, and I'm glad that this building regulation is coming to force. I'm not so sure about all the content of it, but I will explain about that in a minute. But there's two main aims of Part O. So we want to limit the unwanted solar gains in the summer, so that's the sun coming through the window. But at the same time, we need to provide adequate means to remove the heat from the indoor environment. And essentially what that is getting the heat out through either openable windows, or if you can't open the windows, then having some sort of mechanical ventilation to deal with that. So there's two parts to the overheating, and whenever we look at overheating, we always say both of them go together. So we want to deal with both. We want to stop the solar gains coming in so much, so making the window smaller, for example, or providing shading. But we also need to get that hot air out. So it's no good having all the shading in the world all over your building if you can't open the windows and you can't allow that heat to come out, especially overnight, because as we know, at night time, the temperature drops, and that's when we want to open our windows and sort of purge everything out. So that's really important. So there's two sides of it. I will make sure that you sort of keep that in your mind, thinking it's not just one without the other. We can't just stick on brise-soleil and think, oh, that solved our overheating problem, because you still need to allow that heat to get out. And in Part O, there are two options you can go for compliance. One is called the simplified method. Well, it's called the simplified method. I'm not sure it's particularly simple. There's a lot of numbers involved with it. So in the next few slides, I've put all the numbers on, but don't worry, you don't have to remember them. It's just really to show you the simplified method, not necessarily that simplified. Or there's option 2, which is the dynamic thermal modelling. The dynamic thermal modelling is related to TM59. It's what I just spoke about that we have been doing for planning in London Plan since 2018 really, but obviously now the new London Plan is in force. We're doing it for all new London developments. The key thing here obviously is that Part O is a nationwide building regulation. So those developers or house builders who normally don't build in London aren't used to this. This might be a bit of a shock or a bit of a steep learning curve, because building out, in Kent, housing developments going up all over the place, they haven't really thought about overheating. Yes, they might be slightly different style of building, for example, not so many sort of overglazed apartments, but overheating still needs to be dealt with. So because it's a new building regulation, everyone needs to comply, and everyone needs to get an understanding of what it means, because there's no point getting a house built and then going, oh, we need to comply with overheating, because by that point, it's going to be too late. We need to think about this at the design stage. And really, if you've got a problem, change your design or think about other options. I'm sort of driving this home now, so yeah, hopefully. So let's have a little look at the simplified method to start with. So, as I said, this slide, you may not even be able to see the numbers, and I apologise for that. If you really want to look at all the individual numbers, you can go to Part O and have a real look. The idea to put this all up here is to show that it's quite prescriptive and very restrictive. So the simplified method sets restrictions on window areas for your apartment, minimum free areas of the windows, and shading based on the dwelling characteristics. So there's a few dwelling characteristics first, and that's why I've actually put it into this little flow chart rather than in Part O. There's lots and lots and lots of tables you can sort of look through, but this is sort of like a flow chart to give yourself an idea of what the kind of restrictions on your windows will be depending on your dwelling. So the first question we ask is the dwelling cross-ventilated? Cross-ventilation means windows on opposite sides. You wouldn't really, I don't think, and I will double check this, I don't think on a corner, like a window on a corner would count. It needs to be full cross-ventilation. So you say, is it cross-ventilation or not? And once you've decided that, and obviously this has to be done for every single dwelling, don't forget, this isn't just done on an apartment block. Every single dwelling will need to have this, or dwelling type will need to have this assessment. So is it cross-ventilated, yes or no? And then you have to say whether you're in a high-risk location, which is basically London, or a moderate risk relocation, which is the whole of the rest of the UK. So if you're, for example, in a single facade flat in London, you then have to look at what your most glazed orientation is. So as you can imagine, there's more restrictions if you have a south or west orientation, because that's where we get the most solar gains. So you'll see there, and I don't know if you can actually see this, but if we had didn't have a cross ventilation and we were in a high risk and we had a south, most of the maximum area of glazing was on the south side, we'd be allowed 11% windows based on floor area. So, you know, if you had a 70 meter squared flat, sorry, you'd be allowed around 7 meters squared of windows for the entire apartment, which to me seems quite low. Obviously, there could be a bit of argument there with daylighting as well. So hopefully this shows you that it is very restrictive on what windows you can have to comply with the simplified method. You get an allowance for the maximum amount of glazing you can have in the room, but also you get an allowance for the maximum amount of glazing you can have in the most glazed room. Bit of a mouthful, but normally we'd see the most glazed room being something like a living room, where we might want to have a nice sliding door or double doors to a balcony and some other windows. So there's restrictions on that. So the first thing you need to look at is, can you meet the overall maximum glazing of the flat or the house? This is obviously, I'm talking a lot about apartments, but this is obviously relative as well to individual houses. So you need to think about that. And these are restrictions that need to, obviously, when you're doing the design, you need to look at this and think, right, check our windows, check our sizes, are they meeting it? I would imagine that most apartments that we look at, and I'm going to show you some examples in a minute actually, some case studies, probably are not going to comply with this. Furthermore, on the simplified method, not only is it restricting you on the size of the windows you're allowed, but also on the size of how much of that is allowed to be openable. So, excuse me. So again, it's broken down into whether it's got cross ventilation or not, and whether you're high or moderate risk. So as I said, high risk, London. So I've just circled that red one there because this is looking at no cross ventilation in the high risk area, London. And we're saying, what is the minimum free area requirement? It's got to be 95% of the glazing area. That's pretty much every part of your glazing needs to be openable to comply with the simplified method, which I don't think is very realistic, to be honest. As I said earlier, there's lots of numbers on these slides and it's a lot to process, but hopefully you realise that complying with the simplified method is not simple and it's very restrictive. So you're probably going to have to go down the second route. The other restrictions in terms of simplified method is on the type of window. So this one, they've identified, so there's three things. You have to limit the amount of area of your windows, maximize the openable parts of your windows, and then if you have you're on what's called a high risk orientation, which is essentially anywhere going from west all the way around to east. So you've got your west, your southwest, south, obviously, to east. If you've got windows with those orientations, they also need to have one of these other things. So the three blue bubbles I've got at the bottom there. So as well as complying with area openings, free area, you also need to either have external shutters with means of ventilation, a G value of 0.4 of the window. So those of you not familiar with G value, that's essentially how much heat can come through the window. The lower the G value, the less solar gains we get through. This is also related a little bit to our energy calculations, because weirdly, in part L and SAP calculations, we want a higher G value because we want more solar gains to come in, because that will then reduce the heating load. But for overheating, we want lower G value. So a G value of 0.4 is quite low, but you can go lower. And that's probably quite a good balance between doing the energy calculations and the overheating. So when you're looking at this overheating, don't just look at it on its own. Excuse me. I would get something in my throat, wouldn't I? Yeah, don't just look at it on its own. You've got part L as well to look at, which is to do with the energy. And then, so this is a restriction on your windows. So you're going to have to either provide external shutters, a G value of 0.4, or if you've got a south facade, you need to provide overhangs over the window to provide that shading. So you can see that it's part O is asking a lot to comply with the simplified method. And you really need to check your dwellings at design stage. Are we going to comply with this? Let's have a little look at some examples for simplified method. So this is a bit of a basic SketchUp model that I've drawn to actually carry out some SAP calculations for one of my clients. This is a block of flats in London. So it's a high risk area, and we'll put no cross ventilation, probably because all the rooms won't be able to have cross ventilation. So it basically has the hardest targets to meet. So we're looking at one apartment there that I've circled. You can't actually see there what the living room is and not, but I assume the living room is here. This is going to be a balcony. But this to me does not look like a particularly overglazed, apartment. A lot of apartments that I see nowadays has this sort of level of glazing. It makes it a lovely environment to live in. It's great for daylighting. So what we did is we carried out the simplified method on this example flat. And this apartment had its largest glazed facade to the east. The apartment itself, 70 metres squared, quite standard. And the total area of glazing for the whole apartment, nearly 20 metres squared. So it's 18.9 metres squared. And as a percentage of the total area, that came to 26.9%. And if you can remember that flow chart, you won't remember all of it, but on there, I will tell you the maximum allowed glazing for the whole flat is actually 11% for this situation. So it's way exceeding the maximum allowed. So it does not pass the simplified method. Similarly, the most glazed room is that living room, which is around 35 metres squared. And within that living room, there's about 10 metres squared of glazing. I mean, that 10 metres squared of glazing just in the living room alone exceeds the maximum allowed for the whole of Part O. So the percentage of glazing in the living room is 28% of the floor area. So that exceeds it as well. So basically it doesn't pass the simplified method. As you know, there is another method we can look at, and that's what I'm going on to next. But this is just to show you that, generally speaking, the simplified method is quite difficult to comply with, and I can't see a lot of schemes being able to comply. I've also looked at a semi-detached house for those of you who build these sort of dwellings, and if it's in a moderate risk area, so not in London, and it has cross ventilation because it clearly has a front and a back, and it can go all the way through. And it's this semi-detached house, and it's the largest glazed facade is to the south. So the rear is facing south, a lovely south-facing garden, how lovely. And the total area of the whole dwelling is 87 metres squared. When we looked at how much glazing there was, the percentage of the glazing equaled 17%. To me, that just looks like a very standard house. I mean, I think I've got one down my road that looks like that. And that exceeds the maximum allowed of 15%. So actually, this semi-detached house fails the simplified method. So yeah, this was quite surprising to me, and I was thinking, oh my goodness, is anything going to pass? The most glazed room passes, but interestingly, if you move this house around on the site, so if this was a house type that was being orientated differently, the house would comply if the rear was orientated either north or east, but not west. In terms of because obviously if it's orientated with a north-facing garden, the allowable percentage of glazing goes up. So that's another thing to think about. If you have a house, if you're building houses like this and you've got things that are moving around the site, if you find that one complies in one orientation, it may not comply in the other orientation. So what we're going to do, if we find out that nothing complies with the simplified method, what we're going to do is go to option 2, which is dynamic thermal modelling. And this is what I was talking about earlier, that we have been using for London plan compliance since 2018. And this is called CIBSE TM59. And you'll see here, this is the CIBSE TM59 guide. This always makes me laugh because on the front of the TM59 guide, which is written for the UK, by the way, is a lovely villa or something in Provence or somewhere lovely and hot. And they've got these, we've seen this when we go on holiday, these shutters that cover the windows. Now, this is not representative of anything that I've seen built really in the UK, maybe a farmhouse, but nothing new build, nothing that the developers that I work with are doing. So I find this quite ironic that they have put this picture on the front of the TM59 guidance because it's really not. And they've got some lovely shading as well there from some vegetation. But anyway, this is the guidance, and it's a standardised approach to predicting overheating. So this is specifically for residential buildings. It's called CIBSE TM59 because that's just the technical note it's named under, and it's a risk assessment. It offers a lot of greater design flexibility. So where we were looking at the simplified method, we saw that there was lots of restrictions on your window openings and your window sizes and everything really. But if you do a dynamic thermal model, you get a lot more design flexibility in terms of your window sizes. There's actually a rule as well within Part O that you cannot use the simplified method for apartment blocks with a communal heating system. So actually the simplified method, although I've spent quite a long time talking about it, it's probably out the window for a lot of London developers who need to comply with the London plan because they would require communal heating systems to be compliant for district heat network connections. So that's important to know. So if you're designing an apartment block in London with a communal heating system, don't even bother looking at the simplified method because you must use dynamic thermal modelling. And that is because of the heating that, if you have heating pipe work down the corridors, that also obviously causes an overheating issue, which needs to be included within the TM59 assessment. The other good thing about the TM59 assessment is that we can include lots of other things like adjacent buildings for shading, the balconies, the recesses to windows. There's a lot of detail that we can put into the TM59 assessment, which makes it a very powerful tool. A bit of a pain to work with sometimes, but we can really help you to look at different ways to deal with your overheating in terms of window design. So this is the TM59 requirements, and these are taken from the TM59 booklet I just showed you. There's a lot of words here. I mean, you don't necessarily need to understand all of this, but essentially, for natural ventilated, which is my ideal situation where I can say, yes, we're allowed to open the windows, that's great. You can see that window open there, looking out, lovely. Probably wouldn't be allowed to open that window, probably a bit too noisy, but that's what Chris is going to deal with in a minute. So we've got two criteria that we need to meet for TM59. The first one is to do with the maximum adaptive temperature. And the maximum adaptive temperature is not really, because a lot of people say to me, so what's the maximum temperature we can get to before it's deemed to be overheating? It's very much adaptive based on sort of like the climate and the local weather conditions. So if it was a very, very hot day, people are more likely to be happier to be slightly warmer in their dwellings than they would be if it was not a hot day. So it's adaptive to the external temperature. And the temperature difference cannot be greater or equal to more than 1 Kelvin over the adaptive temperature for 3% of the occupied hours of the summer. Again, a bit of a mouthful, but basically our target is 3%. If we go over 3%, it means you failed TM59. So this 3% basically says that there is going to be some hot days in the summer. For 3% at that time, that's okay. We can deal with that. People can live with that. And they're not going to be too hot. But if it goes over 3%, then people are going to start getting a bit annoyed. They're going to feel too hot. They're not going to be able to sleep, things like that. So that's one of the key things we need to think about, is meeting that 3%. The other criterion is related to bedrooms only, and this is really looking at nighttime comfort and how people are going to be sleeping. And that's to guarantee the comfort during sleeping hours. So that just looks at between 10 p.m. and 7 a.m. for bedrooms only, that it can't go over 26 degrees for more than 1% of annual hours. So for the whole of the year, it's allowed to go over 26 degrees for 32 hours, which is a few nights sleep in the middle of summer maybe. But if it goes over that, then it's deemed to not be compliant. So these criterion 1 and criterion 2 specifically for natural ventilation. Where we have either no or limited opportunity for opening windows due to noise levels or air quality, we then look at the CIBSE fixed temperature test, and that is a bit more straightforward. All occupied rooms should not exceed the operative temperature of 26 degrees for more than 3% of the annual occupied hours. So that is where we basically can't open the windows for particular reasons, acoustically maybe, which Chris is going to talk about. So yeah, these are two TM59 requirements. So this just might be useful if you end up getting a dynamic simulation model completed. Maybe we do one for you, and you get your results and you think, oh my gosh, what means pass, what means fail? These are the key numbers you need to look at. 3%, 32 hours. And if you don't have openable windows, then it's just the 3%. So this is what we're looking for in terms of compliance. And we obviously haven't got to the point where Part O is coming to force yet, but I assume the building control officer is going to be asking for schedule of results for all your units showing this compliance. So this is useful to know so that you can start to really have a think about what's passing, what's failing. Here is an example model that was built for one of our clients. One they might be on here, maybe they might recognise it, which is a full model of an apartment block, and you can see there the blue apartment block with the green shading added on. So we've got all the balconies added on. If there was any other shading, we'd add on in green. The pink around it is adjacent buildings, maybe part of the site or local to the site, which you can see there they are causing some shading, and that can really help with the TM59 assessment. What we do for TM59 is we do a full dynamic simulation for a full year. So we get the weather file. We've got weather files that are available to us for that particular area, and it knows all the weather for that year. I mean, it's an incredible amount of data. We create the 3D model in line with the guidance, and then when we run the simulation, it analyses the building every 10 minutes for dynamic changes in temperature, and it actually takes into account so many things. So the weather, the equipment, the occupancy, how the windows are operated. Like every single window in that model there, we have assigned whether it's fixed, whether it's side hung, top hung, what degree, how many degrees can it open to, like 45 degrees, 90 degrees. When can it open? Can it open in the day? Can it open at night? So there's so much information we can put into this, and you can see that it does give us a lot more design flexibility than, say, the simplified method does, where it just limits your window areas. So, this we can really help you with. And when we start building these models and we start getting results out, it's when we can, really manipulate the data and work out what is the best options for you. A key thing I put here, and and hopefully this is something you'll remember, is that blinds, internal blinds, cannot be used to meet Part O compliance. So those of you who have used TM59 in the past for compliance for London Plan, for example, may have added blinds to deal with those solar gains. Part O have decided that internal blinds cannot be used. Now, I feel this is going to cause quite a few issues because we quite often use internal blinds to mitigate overheating risk. So we're going to come up with some issues regarding this, but this is something that it specifically says in Part O. So forget about internal blinds. What I am interested in now about those, maybe they might let interstitial blinds because that's more part of the building, fabric. So where the blinds you have in between two panes of glass, but it doesn't specifically mention that. So it's something that I'm going to be interested to find out. Obviously, a lot more expensive than internal blinds, so something to think about. The other thing that Part O says is that ground floor windows can be securely opened in the day, but they must be shut at night for ground floor windows. And what I'm going to tell you is that when we do a TM59 assessment, if we shut the windows at night, it automatically fails through the passive ventilation. So that's when we need to start looking at mechanical options. So that's how we do it. They're the options. That's what we do. And then what can we do to actually mitigate this risk of overheating? So these are the few options we can look at. I'm going to look at each one of these in terms of window design. We talked earlier about the low G value. So we'd want to have a low G value to reduce the solar gain. Again, this is quite a highly glazed option here. Large fixed pane should be avoided. What we really want is to maximise the openable area and angle of opening to allow that heat to get out. So when you're opening the windows, lets all the heat out, and it reduces that risk of overheating. We need to allow nighttime cooling if we can in bedrooms, so that's windows allowed to be open overnight. As I said earlier, if there's a security issue, that needs to be taken into account. So generally speaking, if you have 100 mil restrictors on the windows, it's not really sufficient to comply. It doesn't give you enough air changes to cool off the room. Also, large balcony doors or sliding doors in living rooms should also be accompanied by openable windows, because generally speaking, occupants wouldn't like to leave like their sliding door, for example, open onto their balcony overnight to allow that nighttime cooling. So although I said earlier, nighttime cooling is important in bedrooms, it's also important in living rooms to get that heat out, especially if those living rooms have a lot of glazing. So it's really a good idea to have some open windows alongside your balcony doors in living rooms. We can look at fixed shading. So this is good because it obviously really controls the solar gains. It can be included in architectural design, but this really must be included at an early stage, pre-planning, and this needs to form part of the overall design. It does obviously affect daylight and sunlight, and the occupant can't control it, so it's there and that's it. It's fixed. It may also impact window cleaning. I think in terms of Part O, they are looking for more of this sort of shading to be used because they're not interested in having internal blinds anymore. So fixed shading perhaps on the outside, or some external shading which is actually movable. So these are quite clever, and obviously again very much intrinsic to the design of the building. These are slidable solar shading, so you could probably have it slid over your bedroom in the day and your living room at night or something like that. So it can be moved for daylighting as well. and it can allow ventilation through the through the louvers. It can also help with winter heat retention. So these can be really useful for shading, and we obviously would then not require the internal blinds. However, they are quite expensive. There's a lot of maintenance involved. Then you can think about all that sliding mechanism, that getting stuck. You need to have openable windows, but the windows need to probably go inwards, because you don't want to open your window out and smash into your external shading. That would not be ideal. So it needs to be integrated architecturally. So I think these are a great idea, but obviously this is going to be for specific sites only, and maybe not appropriate for everything. We've talked a bit before about internal shading. So as I put there against that big red cross, currently Part O does not allow the use of blinds to mitigate overheating. So we cannot use internal blinds anymore to mitigate. I said earlier, I'm going to have a look at whether they'll allow the interstitial blinds, which you can see here, because blinds are actually really useful. This isn't to say people won't put blinds in and use them to mitigate the risk of overheating, but they cannot be used within our calculations, which is a little bit disappointing, because they do work quite well. However, we do get quite a lot of non-compliance in terms of blind installation, because to be compliant with TM59, the blinds need to be installed at base build. So there are obviously other factors that affect Part O, and I said about it earlier as well, like all the parts of the building regulations interlink with each other. Chris is going to talk in a minute about acoustics and their effect, but there's also things about security and protection from falling. So all these things are really important to ensure we reduce the risk of overheating, but we're not obviously coming up against other parts of the building regulations that may be affected. So we've talked about shading. How do we shade the building? What are the different options for that? But as I said earlier, that's just one part of the overheating. So that deals with the solar gains. What we're interested in as well about is getting that ventilation in. So the top one in this is our ideal situation, where we've got no acoustic issues, we've got no security issues, we've got no air quality issues, and the windows can open as much as we like 24/7. And that allows natural ventilation and nighttime cooling, which I talked about in bedrooms, which is really, really important. So we can run the model based on that. And that'd be great if it complies, and we can then say, right, the windows will open to a certain amount, this much is fixed, this much is openable. It's still, I would say, it's still not like super easy to get compliance, even if the windows are fully openable, depending on the amount of fixed glazing, the orientation, all those other things I've talked about. It's not easy, and overheating is a challenge on many sites, I'd say. It starts to become even more of a challenge when we start getting some acoustic issues or security issues. So if there's sort of minor acoustic issues, maybe the windows can open certain times, but not others. So we can have a bit of a hybrid approach where the windows open sometimes. Perhaps we use acoustic louvers to deal with that ventilation, but also helping with stopping that acoustic issue coming in. Because when you're thinking about it, people when they're asleep, it's either going to be noisy or it's going to be hot. And Chris is going to go into a bit more detail in that. The last part of the ventilation strategy, what do we do if there are significant air quality issues or acoustic issues? And essentially, the acoustician says that you can't open your windows for overheating purposes. Obviously, the windows will be openable. We're not going to lock them shut because we need it for purge ventilation for Part F, but that is we can't rely on that for overheating. Overheating needs prolonged time for windows to be opened. And when we get that situation, we have to look at mechanical options. So this is introducing MVHR with tempered air. So this is, I'm going to talk about this in a minute, but this is an MVHR unit which tempers the air coming in. It's not full cooling or going for full cooling. Now, as you might think, actually quite a lot of our sites have got acoustic issues. So we're not going to be able to use natural ventilation. And we're going to be we're starting to be pushed, because this is now going to be regulatory for Part O, we're going to be pushed down this road of actually having to add in cooling, which to me seems completely stupid, because for the last sort of 15 years as an energy assessor, I've been saying, let's avoid cooling, let's reduce energy use, let's work towards net zero carbon, which does not marry up with putting comfort cooling or air conditioning in all our units moving forward. So this, I'm not sure when they wrote Part L, if they fully understood that saying that the windows need to be shut at night in certain situations, it would have this effect, because it's essentially pushing us down this route, which the cooling is more expensive for clients, it's more expensive to run for the occupants, and also it doesn't sit well with me in terms of sustainability. So, but these are the options we come to, and this is what we talk to our clients about quite a lot. And I'll be honest, quite a lot of our clients are on this third level now. So before I hand over to Chris to talk about acoustic side of things, I'm just going to quickly talk to you a little bit about what the acoustic louvers are like and what MVHR with tempered air is. So acoustic louvers look like this. We have successfully had these on some of our sites, one near the M11, which was particularly noisy. And basically they can be specified to allow airflow. Now, you have to be quite careful because for the overheating, will want a lot of free area to let lots of airflow in. But the acoustician is probably going to say, well, actually, due to the acoustic constraints, we need to have, the free area needs to be reduced. And you might then find that the size of the acoustic louvers becomes absolutely unmanageable. They either become really wide or really deep into your room, and then affect the room layout. Basically, it's like almost like a cupboard from the inside. So again, as I said earlier, this needs to be thought about really early on. Is it going to work in your development or not? I think they can work well in certain situations, but I think they're definitely not one size fits all. So obviously, as I said, they're often not viable. And if you haven't got enough wall area, then you're going to struggle to fit them in. It must be included at planning stage, obviously. We have had one client who sort of included almost like what you can see here, actually, like a bit of like this, which could be a brick, could be bricks, or could be a louver, and we left it quite open-ended because we didn't have really sufficient acoustic data at that stage to work out whether it would work. So you could do something like that, and it wouldn't then majorly affect the elevations. But as I said, it needs to have really early involvement with the acoustician and the overheating specialist. And then just a bit about MVHR with tempered air. So this is an example of what the MVHR tempered air setup looks like. And within this is the extra part of the MVHR. So it's still mechanical ventilation with heat recovery, because MVHR alone is not usually sufficient to mitigate the risk of overheating. A lot of my clients say, oh, why can't we just boost the MVHR? It doesn't really provide enough airflow, or it doesn't cool the flat enough or the house enough to reduce the risk of overheating. So this extra cooling box is part of, added part of the system. There's a couple of manufacturers who are doing this now. And this is an option for where windows are required to be shut for acoustic or air quality issues, and it's not cooling. So you should never say that this is, your flat is cooled. It basically locks a few degrees off the incoming air temperature of the MVHR, which can help manage the risk of overheating in those very hot times. This cooling box wouldn't need to be operating all the time, obviously. And the size of this cooling box needs to be thought of. I think it's around 370 mil. Wrong, deep. So think about where you're going to put that. Is that going to be in your ceiling void? You're going to have to put it somewhere like, drop the ceiling in the bathroom a bit. This again is, it's sort of like a halfway house between going to full comfort cooling. And we all know full comfort cooling requires a lot more kit, a lot more expense, and, including design. So hopefully that has given you a bit of an overall view about what Part O is, what our challenges are. I hope I haven't scared you too much. Obviously, we're here to help you. So, hopefully you found that useful. I'm going to pass over now to Chris McNeely from Cass Allen, who's going to deal with the acoustic issues regarding overheating.
Excellent. Thank you, Ellen. Thanks everyone for joining us. I'm just going to take control of the screen. So hopefully that's worked. Great to have so many people here and so many familiar names on that list. So brilliant to have everyone here. So my name's Chris. I'm from Cass Allen. I can talk about the acoustics. So first thing to think about is when is overheating an acoustic problem? And the situation is you're in your property, you're close to a main road or some other noise source. It's a hot day, so you open your windows to cool down the room. And what this does, the analogy is a bit like a hole in a bucket. If you have a good facade facing a road or any other noise source, we'll often design them to achieve a high level of sound insulation. So when you're inside with your windows closed, it's nice and quiet. If you open that window, you're going to let all the noise in. And it puts you in this situation where you have to kind of decide whether you open the window and have a cooler internal condition, or whether you endure the noise. And obviously everyone would make a personal decision at the time based on what they want. So the answer to what would you do, it really depends. There are lots of considerations we're going to whether you open the window or keep it closed. What are you doing? What time of day is it? How sensitive do you feel to heat or noise? How noisy is it? If you're watching TV and it's not particularly noisy with the window open, you might just turn the TV up a bit, and that might not be a problem. Conversely, if it was a particularly annoying type of noise and you were trying to sleep, then you might decide to have the window closed. So there's lots of variables there that change and would affect what decision you make and what you might consider to be acceptable or not acceptable. So looking at what you can expect with a window, although it does let all the noise in when it's open, it does provide a degree of acoustic insulation. And there's been quite a bit of research done on this, but most of the research has been done based on having a window very slightly open for background ventilation. So that's just cracking the window essentially. And that's the research that you can see on the right-hand side here with different figures. Generally, it varies between window types, but it's generally about 10 to 15 dB with a window slightly open. So that means if you're measuring 60 dB outside your bedroom window, you open the window and measure inside, then you'd expect it to be 10 to 15 dB lower. And normally, when we're looking at planning assessments and things, we take a figure of 13 dB as a general reduction. So if it's 60 dB outside, it's going to be 47 roughly inside with the window open. That said, this research is all based on windows being very slightly open. So if you fully open that window and increase the open area, that could be reduced much further. And I think that's something that's going to become critical over the next couple of years as we try and comply with Part O. Because often with the overheating assessments, as Ellen will tell you, it's not just cracking a window, is it? To comply, it's opening the window often, 200 mil or so. So that's something where we need more data and research. For many years, we've been designing properties in noisy areas, whether that be greenfield development close to roads or apartment blocks in the middle of London, etc. And we have these now very well established noise criteria for what's good design when you have your windows closed. And these are given in British Standard 8233, which I'm sure most of us will have seen in planning conditions at some point. So we take the external noise level and then we calculate what the glazing ventilation needs to achieve with the windows closed to comply with these levels. It's only really recently in the last probably 10 years that people have been thinking more about the effect of open windows as overheating has become more of a problem as we're building more condensed housing and the other factors that Ella mentioned that contribute to overheating. People have started trying to establish what is acceptable with an open window and how do you put criteria to that. And up until Part O, we haven't actually had any criteria. The closest we've come is the AVO guide, so the Acoustics Ventilation Overheating Guide, which has been produced in the last couple of years. But even that was short of providing any actual noise limits or number of hours or days that windows could be open versus noise levels. The closest it gets to that is this graph you can see here, which essentially just says if it is very noisy when you open the windows, you should try and limit the amount of time that windows have to be open. But it doesn't really go any further than that. And as acousticians and energy assessors, when we're trying to comply with planning conditions and satisfy local authorities, it's been very difficult because often it depends what the local authority EHO you're talking to thinks about it on what how you deal with it. So there's been a lot of variation in terms of people's perspectives on it. When we asked the group that produced the AVO guide to give us some numbers, the answer really is there isn't the research to support putting numbers in it at this stage. Therefore, it is quite interesting that Part O goes to the level of putting in numbers, and we'll talk about that shortly. A really important consideration, which is kind of forgotten often when we talk about decibels and noise levels, is the type of noise and the character of the noise. So I just wanted to flag this for everyone to think about. I've got a couple of audio clips here of 3 different noise environments that you might sometimes find near to residential development. I'm just going to play them through. Just encourage everyone to have a think about what they would think if that was outside their bedroom window, say. So you probably thought that the road traffic noise was the least annoying. And personally, I think the soaring noise is the most annoying, but I'd also be quite annoyed by the pub beer garden noise. So that's really important, because when you're listening to those, they're the same noise level, they're just different types of noise. So when we're thinking about what might be acceptable in a habitable room in a new development, we really do have to think about what type of noise it is as well. And that's not covered in Part O, but it's something we should be thinking about for good design. Really important consideration here is Ellen has talked about all the very good things that we can do to help with overheating, and most of them are really integral to the design of the development. And I've produced this slide here. So it shows the REBA stages, which hopefully everyone's broadly familiar with. So obviously we work through these as we're completing new projects. And the blue highlighted box there shows where we're in the planning process. So we're working out, we've got a site, we're working out what's going to work for that site, what we're trying to achieve, and we're putting together the basic design, what it's going to look like, materials, etc. And the building regulations phase only really comes into play around about the time where the planning application has been determined. So you get your planning consent, and then you register it with building control and start cracking on with the detailed design. So the building regulations apply essentially after the planning application. And this is really important for Part O, because a lot of the good overheating design options that we have, that Ellen set out, is all to do with the very fundamental to the look, appearance and design orientation and layout of developments. So the right time to be thinking about those is at the planning stage, whereas the building regulations come into force much later. So we've got this issue here where we've got very stringent, or strict I should say, building regulation requirement on overheating. The best way to deal with it is actually so much earlier in the project. And we already see at times where we're designing to the London plan and we have to comply TN 59, etc. Situations where it's considered quite late on in the design, and at that point you're limited to glazing types or the ventilation system and the duty of it. And beyond that, there's not much more you can do. So the key message, I think, from this presentation is this is something that we should all be thinking about when we're looking at sites and designing sites very early on. Where are we going to have the issues and how are we going to deal with them? Because we will have to deal with them now. Okay, so I've just marked on there as well when we would normally be involved in terms of preparing noise assessments for planning applications. Often it's towards the end of the planning design stage. I think that needs to be sooner now. And same with detailed noise assessments where we're discharging planning conditions. And it's a similar story for the energy assessments as well. Okay, so on to the specifics of Part O and the actual noise requirements. And this is it. It's just 3 paragraphs, but they're quite powerful in what they require. So they set very strict limits for noise levels in bedrooms at night, and it's only bedrooms at night. There's no noise limits for living rooms or any rooms during the day. And the idea behind this is obviously that people can have good quality sleep and they're not disturbed in the night, or put in that situation where they have to choose between high noise levels and thermal comfort. The thing about these limits is they're very low. So we said before that the typical outside to inside noise reduction of an open window is about 13 dB. So you can take these internal limits and say, if we're going to use an open window to control overheating, which, as Ellen pointed out, is your first port of call in any energy assessment, and that's what you're ideally hoping to achieve. It's very difficult to not achieve that, to achieve thermal comfort without an open window. It equates to 53 dB LAQ externally, or 68 dB LA max. So the LAQ is the average noise level over the night, and the LA max is max is noise levels during individual events. So that might be a trains going past or cars driving past. And they're quite low noise levels. I'll show you some examples of sites in a minute where those, showing where those limits would be exceeded. But many developments will exceed these limits, and therefore the part of the requirement is that you can't open those windows. So you need to start looking at alternatives. That's going to result in a failure straight away in your energy assessment, and therefore your mitigation will be required. And as I say, hopefully, if we do a good job of the design at the start of the project, then solar shading and all those other good things will be included. But if they're not, we're going to be limited to mechanical ventilation, purge ventilation, etc. Also, whilst it's not specifically said in Part O, if you're having to demonstrate that you can avoid overheating in bedrooms with the windows closed because you're exceeding these noise limits, then the only way to do that really is through the thermal modelling exercise. So this noise criteria may push people down the second method of compliance, so the thermal modelling method, because obviously the simplified method relies on open windows. Okay, so a couple of examples of sites here. So we've got two to hopefully give you a flavour for where these limits would apply. This first one is a greenfield site, new residential development, large number of houses. It's situated next to an A road, which is shown on the right-hand side. In fact, both roads to the south are A roads, but it's the A14 on the bottom right. So obviously a very busy road. An A road to the other side, but less busy, single lane, and then a more sort of local road running through the middle of the site. So this is a site we've already worked on. So we've taken the noise model that we've produced, which we would normally produce for planning, etc. And the model shows here in red the facades that would be affected by this Part O requirement for windows to be closed in bedrooms, and the facades in green are those that could keep their windows open at night. So this kind of shows that for a greenfield site close to roads or railways, you're probably only going to need to worry about those facades directly facing the sources, and any facades that are screened from the sources by the first row or line of houses are probably going to be okay. But obviously the next thing you've got to think about there is, well, which of those facades are going to be the most likely to overheat, and that would be the south facing ones. So you could say very quickly in this case that which facades you're going to have to worry about most, and that's where at a very early design stage we can look at it and say that's where you want to be thinking about solar shading or these other measures to avoid issues at the regulation stage. So second example, again, another type of development we work on very often, which is mixed use, large scale residential development in a built up area. So this is actually Brighton, but it could be London or any other town or city. And we've got a railway and a road to the south. The railway is shown on the bottom right, road bottom left. And the road and railway aren't particularly noisy in compared to some other roads and railways we build close to. So that's worth bearing in mind. But if we look at the modelling predictions again for this site, you can see the Part O requirement penetrates further back into the site. And that's common in built-up areas where you have reflections off buildings and things, which mean that as you move further back into the site, the noise will drop off at a lower, will drop off more slowly. So here you can see most of the facades are this Part O requirement would apply. So this is a site we'd want to be looking at thinking about very early in terms of how we're going to deal with the overheating. So that covers, obviously the acoustics is a fairly small part of the Part O requirement, but a very important one. And these conclusions, they're kind of shared conclusions, aren't they, Ellen? Yes. From the two overheating and the noise side. So Part O must be complied with, and there will be issues if we don't think about it early in the design. And we saw that with Part E, which relates to sound insulation. I mean, it was 2003 when it came in, so a long time ago now, but there was a few years where compliance, it took a while for developers to catch up with it, or some developers to catch up with it. It caused lots of problems. So the purpose of this presentation really is hopefully all of us here can avoid these problems by thinking about it early, because they're always painful. The acoustic requirements and the blinds as well that Ellen mentioned, that they're going to exacerbate the overheating problems that we already come across in developments in London. And as Ellen says, this regulation applies throughout the whole of the UK now. So if you are a developer that isn't involved in much work in London, this is going to be very new to you. Full TM59 assessments will be more common, and building control officers are going to be asking for Part O reports. So obviously we'll be putting plenty of those together. One thing as well is Part O compliance doesn't necessarily mean good design. And a good example of that is when I was talking about the different types of noise that we have. You might want to go above and beyond the Part O requirements. For example, for bedrooms, if you have a particularly annoying type of noise on the site, for example. And that's similar to Part E as well, where Part E has minimum standards for sound insulation between dwellings, but often we'll be advising developers to do better than that, to provide better quality accommodation. And that's fairly standard now.
Thanks. That's really, really important. I think the implications with the acoustics linked in with Part O is a really important part of it. And I'd like to just reiterate, just for the final point, that what we've seen is where windows need to be closed for acoustic reasons, that we might be pushed down this mechanical cooling or enhanced ventilation route, which affects energy use and obviously goes against the cooling hierarchy. So it's just something that, I said earlier, the ideal situation is the windows can all open, but where we've got these acoustic issues, we are now being regulated regarding this, and it's going to obviously affect the overheating. So certainly assess risk early to avoid problems is the take-home message.
Yeah, absolutely. Okay, thank you.
Okay, hi everyone. Thank you, Ellen and Chris. That was really interesting, and I hope everyone else got what they needed from that. But obviously, we've got a few questions, which is fantastic. Firstly, just apologies at the start there if anyone had any trouble getting in. That seems to have been resolved, but obviously if anyone did miss anything at the start, just a reminder that you're going to be sent a link through to the live replay, well, the replay of the live event rather, and failing that, you can also attend the next one at the end of May. So that's fantastic. So
we'll just come and listen again if you loved it so much.
Well, yeah, absolutely. You might have it on repeat in the background. But I have to mention the appreciation for your pun, Ellen, the simplified method being out the window. That got a lot of upvotes. So
yeah, that wasn't actually intentional, but thank you.
A bit of moonlighting as a comedian on the side. So in terms of the real questions, we've got one here. Is the glazing percentage based upon the pane area only or the overall window unit? Very
good question. I don't know exactly. I'd assume it would be the overall window unit, because when we're looking at the TM59 assessment, we take into account a frame factor. However, on the simplified method, I assume it would be the entire window, because it would be very difficult if you had lots of different panes to work out the percentage of that. But that is a really good question, which I don't know the actual answer for, so I will find that out and let you know.
Okay, yeah, so what we'll be doing is we'll be taking all of the questions from the session and going back, probably pop out an email or something with a link, or cover any of the questions in further detail later on. Keep an eye on the social media and on your emails as well, so we can follow up. Great question. We've got another one here. Has impact of exposed concrete structure been considered as a possible strategy to address overheating, accepting there may be competing standards on acoustics?
Yes, certainly. As I mentioned in the presentation, the use of materials with high thermal mass can be included within the TM59 assessment, and they do have a really good impact. So, for example, if you were comparing a timber roof with insulation versus a roof with a concrete slab in it, you'll find that the rooms with the concrete slab roof above it won't overheat as much. Therefore, if you expose it as well, it will have a beneficial impact. I'd say everything to do with the fabric has a small impact on the overheating, but not as much of an impact as the size of the windows and the opening of the windows. So certainly it comes into it, but you're not going to see a massive change in the results if you've got a very highly glazed room, for example.
Perfect, thank you. We've got one here from the acoustic side, I think. So do the acoustic requirements consider human adaptation to noise, if that's a thing? I.e., is the overnight limit the same for both urban and rural locations?
Yeah, it's a very good point. I mean, they don't consider the location or the type of noise at all, the requirements in Part O. They apply simply to the absolute noise levels. And I guess that's my point about the different types of noise potentially being more annoying. And I think the point about human adaptation it comes into that. So, for example, if you live next to a railway, people do say they get used to the noise of trains going past. I don't think you would ever get used to the noise of a grinder from a workshop. So it doesn't include any consideration of that, but I think it's a really good point. It's something we would try and think about for good design, beyond the requirements of Part O.
Fantastic, thank you. I think we've got time for a couple more. There appears to be a disconnect with the levels in BS 8233 for Chris. So which do you think should prevail?
Well, so the criteria in 8233 would normally be applied to the closed windows condition. If you can achieve them with open windows, I mean, that's ideal, but that's fairly rare from the projects we see, because obviously we work on projects in noisier areas. And it's generally accepted that it's okay to exceed those criteria if it's an overheating condition. So, for example, if you're opening your windows, and it increases the levels 5-10 dB over those 8233 levels. If that's not all the time, that's acceptable. So the 8233 levels would definitely apply in the closed window condition. For the open window condition, the Part O ones now apply, but again, you might want to look at those on a site-by-site basis to determine whether they are the right limits, if that makes sense.
Okay, thank you. This one might be relevant here. If you say the acoustic louvres require regular specialist cleaning or filter replacement?
Do you want me to comment on this?
Yeah, do you know more about? I know a little bit about them. You probably know a bit more about acoustic louvers, Chris.
Yeah, I think this is something this is one of the problems with the acoustic louvers at the moment is that it's quite a new thing. We've only seen them in developments over the last couple of years, and we know from the developers who have used them that they've caused problems in terms of getting supply, getting them to fit in with the other facade elements. I'm not personally convinced that they are a good solution to this problem. I think solar shading and stuff to try and avoid the reliance on open windows first, because I don't think an acoustic louver is comparable in terms of what it offers the resident to an open window. It's not the same thing. You don't really have fresh air blowing through it. So I'm not sure about the cleaning, but I wouldn't be surprised if they're very difficult and painful to clean, and they don't get looked after, particularly if you're looking at housing association developments or buy to rent or whatever. So yeah, I think I think we'll find out, but I think there's going to be problems with them.
Sure, thank you.
Yeah, I just wanted to say thanks to James Rivers, who has stated that in Part O it says glazing area. So where the first question was, is the glazing area the window area? Part O says the glazing area. So thanks, James, for that, for letting me know that.
Oh, great. Yeah, thank you. I saw that pop up in there. So, yeah, thanks for popping a reply in there. I think we covered Neil's
Yeah,
question.
that's very similar to the question about high thermal mass from concrete. So yes, it will be taken into account, obviously, in the TM59 assessment if you have a closed brick facade which has a higher thermal mass. It does have a small beneficial effect, but yeah. So when you were comparing, say, brick versus aluminium rain screen cladding, you would find the brick would have high thermal mass and probably perform a little bit better in terms of the overheating performance.
Great, thank you. Let's find a couple more in here. We've had some, just to make you aware, we've had some questions about costs and things. So we've popped a reply in there, but best thing to do is use the contact details on the screen or the ones you're going to receive via email at the end, so you can contact Chris or Ellen about costs and things. Obviously, it's a very big subject and very subjective, so it's best to do that offline. So here's one. Will Parto consider the use of openable windows when apartments are mechanically ventilated in the future to address criterion 3?
Potentially. So if the windows, if it's mechanically ventilated and you want to include that in your assessment of the overheating, then obviously the only way to do that is through the full dynamic simulation modelling. So I don't know if you were specifically referring to the simple method, because that really is just related to window sizes, open windows. But if you include the mechanical ventilation, yeah, I mean, you could probably end up anyway if you've got mechanical ventilation with a bit of a hybrid situation where the windows can open and you've got mechanical ventilation. So potentially, yes. I don't know if that fully answered your question though.
Okay, thank you. Got some more good ones. If you had an exposed concrete ceiling for thermal mass, would this be impacted if you put a plaster and skim on this, or a suspended ceiling?
Yeah, it would be slightly impacted, because basically when we do the model, we build up the construction. So it would have a slight impact because it wouldn't be fully exposed if you put the plaster or the suspended ceiling over it. But the fact you've got that thermal mass within the overall construction will certainly help. So yeah, basically everything you put into the construction is accounted for within the model.
Thank you. We've got another good one here. This one's a little bit about the transitional period for implementation of Parto on new sites.
Sorry, Chris, I think we answered one of these, but I have actually got a slide on this which I didn't put in. But essentially, there is a year's transition. So basically, I said new Part O comes in June 2022. So if you submit your initial notice after that date, then you are automatically required to comply with Part O. So this might be sites that are currently going through planning. If you submit your initial notice before the 15th of June 2022, you have a year to start that to be under the current regs and not fall under Part O. But it's now done on a plot by plot or block by block basis. Whereas in the past, this also applies to Part L, which is quite important. Whereas in the past, if you've got the initial notice in for your site, it covered the entire site. We've got some sites which are still using SAP 2009, for example, which is very out of date. But now they won't allow that. So if you've got a phased site, and we've got a few of our clients with this where they've built some of the blocks already, but they've got some they're not going to get their initial notice in, or not going to make a start on the site on that particular block. So putting your, for example, putting in your foundations, then it's going to fall under the new reg. So you have a year's grace if you've already submitted your initial notice. But if you don't submit your initial notice before the 15th of June, then you automatically go under the new Part O, the new Part L, F, and S.
Perfect, thank you. This one's a good one for regarding the acoustics. So would height of the apartment block make any difference in terms of acoustic requirements from surrounding roads, for example, and does Parto recognise that for compliance?
Yeah, absolutely would make a difference. So when we're looking at the noise levels across the development, we will use a model typically like the ones I was showing you. and they will calculate the reduction in noise as you go up stories, because essentially you're moving further away from the noise source. So that would affect the external levels on the facades, which would then affect whether the Part O criteria was exceeded or not. Also, the models would factor in screening, where you might have, an apartment facade with then more blocks behind. Obviously, the blocks behind will benefit from the screening. So modelling is quite a powerful tool that we have now to assess the change in noise levels across all windows in the development.
Okay, thank you. We've got a few more flowing in, a few more upvotes. Regarding TM59 checks.
So you can model it to any guidance you want, really, but you're correct. This is where there is a disconnect between TM59 for planning for London Plan and Part O, because you're right, TM59 does allow blinds, but Part O doesn't. So we could certainly, and we have to do this anyway for London Plan, run 2 simulations, one with blinds, one without blinds, because although TM59 allows blinds, it does stipulate quite a few requirements, and says, really you should try getting to comply without blinds. And I feel that is why in Part O they have decided to say, no, you can't use blinds at all. And also because there's, issues with them actually getting installed. And if you have blinds installed, another key thing to think about is that they mustn't interfere with the openable window. So if you've assumed in your simulation that the blinds are down and the window open, you can only do that if the blind is actually attached to the window. You can't have a roller blind in front of the window and the window open behind it, because you're not getting any air flowing. So blinds have been a bit contentious for a while. We can certainly, we were doing it for Part O for building regulations, we wouldn't be allowed to use the blinds in that simulation.
Okay, thank you. I think we've got just maybe one more. So this one's regarding the internal daylight levels and the percentage of glazing. How can this be balanced? So I guess that's for you, Ellen.
Yeah, I mean, this is a tricky one, isn't it? As I said, there's a lot of requirements. There is a disconnect between them, even between Part L and O, which we deal with every day. But obviously, daylighting is a key requirement for planning, and it's going to be hard to balance this. And this is why I think, when we said about the simplified method being restrictive, if you need internal daylighting to be improved, you're going to have to do the full dynamic simulation modelling, and even before overheating came into it, we've still had sort of issues between disagreements between what we can do for daylighting, what we can do for energy, and what we can do for overheating. So it needs to be carefully balanced. You're correct. I don't think there's not a real answer for that, but yeah, it needs to be considered.
Sure. Okay. Thank you. Well, I think that's kind of answered all the most useful questions in there. If we didn't get around to your one, or if you've got any other specific questions, please feel free to follow up with the contact details on screen, which will also, as I've mentioned, you'll receive afterwards. But yeah, we hope that's all been helpful to you. And again, if you didn't catch the start, do feel free to join the next one, or come back and watch the recording. But I'll take the opportunity to say thanks to everyone for joining. Over to Ellen and Chris. I'm sure you'd like to just wrap up now, and we can end the session there.
Yeah, lovely, thank you. Just thanks everyone for joining. Hope you found it useful. Obviously, any questions regarding anything to do with overheating, carbon, energy, planning, Part L, anything to do with sustainability, please do contact me at Whitecode, and I'll be more than happy to help.
Yeah, thanks everyone. Any questions, let us know. And yeah, thanks for joining.
Thank you. And bye for now.
Thanks.
Thanks everyone.